Dinosaurs are not extinct. Although the mighty Tyrannosaurus won't make an appearance on your morning commute to work, you won't see a pack of troodontids leap over your back garden fence, and the vast herds of hadrosaurs are a thing of the past. Dinosaurs still walk among us in the form of birds. All birds are descended from theropod dinosaurs. This is not just a theory, but a scientifically proven fact. Birds aren't related to dinosaurs. They are dinosaurs, avian dinosaurs. With the End Cretaceous, or KPG extinction, all of the non-avian dinosaurs perished and became extinct, leaving behind a world of relatively small creatures. Among them were the feathered ancestors of the theropods, some of which fluttered around from branch to branch, some of which stalked the forests on long earthbound legs. If you look outside your window right now, regardless of where you are in the world, you'll probably see a bird. Depending on your location, this could be anything from a chaffinch to a cardinal, a gull to a gnatcatcher, a buzzard to a bird of paradise. Over 10,000 species exist today, and they compose arguably our most beautiful animals. Brightly colored plumages and beautiful songs have inspired naturalists, birdwatchers, poets, authors, musicians, and painters over the course of human history. But it is only relatively recent science that places these amazing creatures in the same family tree as the now extinct non-avian theropod dinosaurs. In today's video, we will be exploring this ancestry in detail. How exactly did we go from dromaeosaurs to ducks, doves, and dunlins? The journey is long and often convoluted, spanning millions of years of natural history. But it is indeed a fascinating tale. We will take a look not only at how these creatures evolved, but also some of the marvelous forms of avian dinosaurs that thrived throughout the deep annals of prehistory. Our journey begins in the forests of the Jurassic period, and for the foreseeable future is still yet to conclude. As long as the birds are singing in the trees and skies of our planet, the dinosaurs are still with us. The similarities between extinct, non-avian theropod dinosaurs and modern birds are plentiful. The key similarities are obvious. Feathers. All birds have them. Plenty of extinct theropods had them, and they can provide an array of different functionalities and benefits. Feathers can help camouflage a bird, or to make it more colorful and attractive to a mate. They can serve to keep a bird warm, or to allow its sleek, streamlined movement in the water. Primarily, though, the feathers of many birds allow these creatures to fly, something that their non-avian ancestors, as far as we know, could not do. Birds and non-avian theropod dinosaurs also both possess very similar foot structures, with 4 digits tipped with claws. In the non-avians, these claws were used primarily for tearing at flesh, useful and deadly weapons that could allow a dromaeosaur, the bird's closest extinct relative, to bring down creatures much larger than itself. Birds, however, use these features primarily for gripping onto branches and perching. Some birds have taken this back to the time of the dinosaurs. birds of prey and large ratites, such as cassowaries, use these claws as deadly weapons for attack and defense, making them some of the most respected and feared creatures in nature. It is undeniable that modern birds and extinct theropod dinosaurs show very similar traits. The birds, in fact, are most closely related to the dromaeosaurs and the troodontids. The former include the famed sickle-claw raptor dinosaurs, such as Velociraptor, Dromaeosaurus, Deinonychus, Utahraptor, and Pyroraptor, among a whole host of many others. The latter are a slightly lesser-known group of lithe, slender theropods, with such examples including Cynornithoides, Cynovenador, May, Latenovenatrix, and the wastebasket taxon Troodon, which may or may not have been valid at all. These dinosaurs were maniraptoran Coelurosaur theropods, closely related to the Tyrannosaurs, Therizinosaurs, and Ornithomimids, amongst others. The dromaeosaurs and troodontids were all feathered, primarily carnivorous, successful groups of dinosaurs, agile and lightly built. They are often depicted as intelligent pack hunters, although evidence of this is lacking. Like the birds, they were diverse. The largest of these groups included creatures such as Utahraptor, a roughly 6-meter-long apex predator of the iconic Hell Creek Formation, whereas the smallest included the popular Microraptor, a tiny dinosaur with a coat of iridescent feathers that was perfectly adapted to gliding from tree to tree in the forests of Cretaceous China. In the Jurassic period, it started to become difficult to determine where non-avian dinosaurs ended and birds began. In the early 1860s, a fossil was discovered that would change everything. We knew about the evolution of birds at that point, setting us on a path to several paleontological revolutions. Archaeopteryx. You'll likely have seen an illustration of this creature if you've ever read a book on dinosaurs. Usually in older books, it was the only feathered creature depicted, alongside skinny, shrink-wrapped dromaeosaurs and other large theropods. Roughly the size of a crow, and known from 12 immaculately preserved individuals, Archaeopteryx was a bird unearthed from Germany's Solnhofen limestone. This little creature was akin to a non-avian theropod in form, similar to many other known species, with its long tail, clawed digits, toothed jaws, and bipedal stance. But these fossils show distinct proof of feathers. This creature was a bird, but a bird that showed distinctly dinosaurian traits. This led to a common German name for the animal, Urvogel, or first bird. Archaeopteryx was concrete evidence of a sort of intermediate fossil between one group of organisms, the dinosaurs, and another, the birds. The scientific world was shocked. For the next 100 years, opinions on what exactly this creature was were rocked back and forth. Could it fly? Did it glide? Did it even live in trees? Was it a dinosaur or a bird? Paleontologist John Ostrom, a key figure in the dinosaur renaissance, the scientific movement which saw the world portray dinosaurs as energetic, diverse creatures, as they were portrayed in Jurassic Park at the time, had a leading theory in the 1970s. Ostrom suggested that Archaeopteryx was a creature more akin to a dinosaur than a bird, and that it hunted on the ground. Greg Paul, in the 1980s, took this theory into his own hands, suggesting that not only did Archaeopteryx live on the ground, but that it didn't even live near trees at all. He figured that the creature lived in arid landscapes, where trees were sparse, but that it was capable of flight. He suggested that it fed on insects like a swallow or a swift, hawking across the water's edge to catch its food. He was also the first scientist to place Archaeopteryx in the dromaeosaurid family. Today, views are still conflicted, but we do know some of the facts. Archaeopteryx's teeth suggest that it did indeed eat insects, but it possibly strayed into vertebrate territory to supplement its diet. Perhaps small reptiles were also taken. Whether this little creature could fly or not is still a hot topic of debate. There are those that think Archaeopteryx could push itself off the ground with ease, and there are those that claim that it was not suited to a life in the trees. It did indeed live in an arid environment, and generally paleontologists have noted that its feet are flat and adapted to a life on the ground. Archaeopteryx played a pivotal part in helping us to understand the links between dinosaurs and birds, with its numerous crossovers in terms of anatomy and lifestyle. Today, it is agreed that Archaeopteryx is a dromaeosaur, and that it is closely related to birds. But science is science, and the debate rages on in the background. Based on the shared features between Archaeopteryx and early birds, it didn't take scientists long to theorize that birds are simply just another offshoot of the theropod family tree. In the Jurassic period, creatures similar to Archaeopteryx and its relatives began to break off from the norm, adapting their feathers further as their environments changed and became more sparsely vegetated, thus releasing the precious power of flight. Through trial and error, and millions of years, the avian form was perfected, and by the end of the Jurassic period, large numbers of birds were calling and fluttering high amongst the trees and open airways of our prehistoric planet. As we continue to unearth more and more species of extinct theropod dinosaur, we come to learn more and more about how these creatures have evolved. Recent discoveries in China have shown that some of the non-avian dinosaurs that existed throughout the Cretaceous were more bird-like than we once thought. And recent depictions of creatures, such as Anchiornis and Microraptor, show these creatures as almost interchangeable. We have even started to uncover the specific colors of some of these early dinosaurs' plumages, which add to this further. We'll say it once more. There is no doubt about it. Birds are dinosaurs. Once the birds had evolved, they quickly spread out into multiple different forms, functions, colors, and sizes. For the majority of the Mesozoic era, the most widespread and well-known group of birds was the enantiornithines. The vast majority of these birds were relatively small, retained the teeth of their dinosaur ancestors, and possessed small, hooked claws on their wings, something that has vanished in pretty much all modern birds. Over 80 species of enantiornithine birds are known, and they don't compose all of the birds extant in the Mesozoic, but they were indeed widespread. Many of the genera extant throughout the Mesozoic resembled modern-day passerine birds, or perching birds, but with a significantly more dinosaurian twist. Alexornis, for example, was a small wren-like creature, which likely lived in trees and shrubbery in late Cretaceous Mexico. Parvavis was more akin to a bird of paradise, with its long tapering tail feathers on the end of a plump, short body. Euonychuavis was magpie-like, possessing a long fan of tail feathers, which may have been used for display purposes to attract mates. Some enantiornithine birds were more atypical, however. Falcatacali was a creature which recalled the modern-day toucans and hornbills. It retained the lengthy snout of its dinosaurian ancestors, with only a single tooth in its mouth. Roughly the size of a crow, it is known from fossil deposits in Madagascar, where it lived alongside several species of non-avian dinosaur. Hollanda, native to late Cretaceous Mongolia, was much more similar to a wading bird, with long legs and a slender bill. Stranger still were the Avisaurids, a group whose birds were very similar to the dinosaurs they evolved from, retaining appearances very similar to dromaeosaurs. Mirarchi is one such bird, which lived in the western United States during the Cretaceous, where it would have coexisted with dinosaurs such as Cosmoceratops and Parasaurolophus. Neuquanornis, another Avisaurid, looked superficially similar to the aforementioned Archaeopteryx, although it lacked the long, bony tail. Slightly larger was the family's namesake, Avisaurus, which would have lived in floodplains and rivers around where the western interior seaway would have cut through North America in the late Cretaceous. The enantiornithines were by no means the only Mesozoic birds, however. A good place to discover the early diversification of avian dinosaurs would be the forests of Cretaceous China, where many different bird species started to fly through the trees and across the lakes. Confuciusornis is one such bird, a well-known little creature which was common to the area. With a heavily feathered, plump body and long, tapering tail feathers, this little bird would have been a master of display as it fluttered about the trees. Many specimens of this little bird have been uncovered in a crushed state, which until very recently has made it difficult for scientists to describe exactly what it may have looked like. Search for Confuciusornis on the internet, and you'll likely be met by a number of differing body shapes and forms as a result of this. Jehalornis lived in these forests too, another crow-sized creature which would have flown from tree to tree, feeding on the seeds of the native cycads and ginkgos the region had to offer. It is often depicted in a similar manner to the turacos of modern-day Central Africa. Colorful birds with elaborate head crests used for display and communication purposes. Yanornis was more surprising still, also native to Cretaceous China. It was a definite piscivore, feeding on the fish that thrived in the lakes in what would one day become China's Liaoning province. Superficially, this bird would have resembled a tern or gull as it dived on long, steady wings after the fish it hunted. But in terms of the evolutionary record of birds, gulls and Eunornis are a long way apart. Towards the coasts, a whole new group of Mesozoic birds were staking their claim to the seas and oceans of our prehistoric planet. The Hesperorniths were a group of birds that visually would have resembled penguins, only with exceptionally long necks and strange fin-like feet. The most famous is the group's namesake, Hesperornis, which would have thrived in huge colonies along the shores and beaches of the United States in the Cretaceous. The Hesperorniths were among the most notable and large of the Mesozoic birds, and would have lived and hunted much like modern-day loons, grebes, and cormorants, diving after their prey before returning to their colonies on the shoreline. They would have been sleek, capable swimmers, which would have been coexisting with some of the most infamously terrifying creatures of the Cretaceous: sharks, mosasaurs, and giant theropods. While some species were at home on the coasts, creatures such as Brodivus were freshwater Hesperornithine birds, feeding on the fish that thrived in the interior waterways of Cretaceous North America. Some of the most spectacular and famous Mesozoic birds lived throughout the late Cretaceous. Many older dinosaur books featured a bird known as Ichthyornis, a toothed species which would have lived and looked much like a modern-day herring gull. Although it was named because of its fish-shaped vertebrae, this bird would have thrived in large numbers on diets of fish in what is now the central United States, presumably noisily flocking over the western interior seaway, above the shadows of the mosasaurs. Over in Europe, specifically southern France, the largest birds yet were beginning to evolve. The ones that would lay the foundations for the titans of the Cenozoic. Gargantuavis, as the name would suggest, was a massive 2-meter-tall bird, which would have looked and lived much like a modern cassowary. Flightless, it would have walked alongside the dinosaurs of the region, disproving the initial theory that large flightless birds did not evolve until the non-avian dinosaurs had died out. Early ducks also began to evolve in the Cretaceous. Teviornis, native to Mongolia in the Cretaceous's final stages, was uncannily similar to modern ducks, in the sense that it had a broad, flat bill used for dabbling through the water. But it was more similar in form to a stork or crane, wading along the water's edge on long legs, lowering its lengthy neck down to the water to feed. Despite the strange appearance, it was still tiny. At around 15 centimeters long, it was smaller than most modern ducks. The ducks had even made it to Antarctica by the end of the Cretaceous. Vegavis was one such genus. Roughly the size of a goose, it was pretty much typical in form and function. But it was the first Mesozoic bird to be discovered from a group existing into the modern day. For a long time after the non-avian dinosaurs' claim to the Earth came to a close, many creatures that existed in the undergrowth were small. Shrew-like creatures bounded through the undergrowth, and the first lemur-like animals crept through the trees. But they were not alone. Birds were a constant presence in the Paleocene and Eocene forests of the early Cenozoic era, and ranged greatly from small, fluttering species to large flightless animals. In the End Cretaceous extinction event, 4 major groups of birds persisted into the Cenozoic. These were the paleognaths, which include ostriches, emus, and their relatives, and Suriformes, which include ducks, swans, geese, and their relatives. Galliformes, including creatures related to pheasants, grouse, quail, and turkeys. And finally, the Neoaves, which comprised many groups of modern birds. Among the Neoaves are all the extant groups of birds, from hawks to flamingos, from grebes to flycatchers, from hummingbirds to pelicans. Many of these groups were yet to evolve until the late Cenozoic, but various groups were widespread and flourishing. Seabirds, such as Australornis, soared along the coasts, while early relatives of penguins, such as Crossvalia, gathered in large colonies below. In the forests lived early relatives of owls, creatures such as Burroornis, that sported large forward-facing eyes like their modern descendants. Some of these ancient birds grew huge, however. Gastornis, placed in a family named after itself, was a giant among dwarves, wandering the woodlands on pillar-like legs and sporting a deep, bulky beak on the end of its face. Recalling the mighty theropods, this was the first example of birds growing to become some of the largest land animals on Earth. Debate persists as to whether Gastornis was a herbivore or carnivore. Elsewhere in the early Cenozoic lived Presbyornis, a creature related to ducks that took on a form more similar to that of a flamingo, with long, graceful legs and a winding S-shaped neck. Neocathartes shows an example of a bird related to cranes and rails, taking on the flesh-eating lifestyle of a vulture, in yet another example of modern bird groups filling atypical ecological niches in the prehistoric world. As the Cenozoic progressed, so did its birds. The later epochs of the Cenozoic era saw the induction of the mighty terror birds to the world. These creatures, many of which were taller than adult humans, stormed the American grasslands on powerful, long legs, in a manner akin to the extinct Tyrannosaurs. Phorus rachis is the most commonly known genus, but Kelenken was the biggest, a colossus that used its beak as an axe to tear down the herbivorous mammals it fed on. In the Pleistocene epoch, birds were growing massive all over the world. Apiornis, otherwise known as the elephant bird, conquered the island of Madagascar, whereas Dinornis, the giant moa, thrived on New Zealand, up until the Maoris settled in the area and wiped them out. Geniornis was a bizarre creature native to Australia, ostrich in form, but more closely related to ducks. Giant owls thrived on Cuba, and colossal storks made their home in Southeast Asia. Argentavis was a gigantic relative of condors that thrived in South America, and Pelagornis, some of the largest flying birds ever to live, were pelican relatives that thrived by the coasts and oceans. In their massive shadows, however, newer groups of small birds were steadily evolving. Passerines, the massive group of perching birds that contains around half of all known species, emerged in the Cenozoic. Passerines can now be found in almost every corner of the planet, comprising a huge number of families and genuses. The mammals might be known for conquering the Cenozoic, but the birds simply cannot be ignored. The diversity and range of modern-day birds is simply astounding. Over 10,000 species are currently in existence, and these species exist on every continent on the planet. Birds are extreme creatures, ranging in size from the massive common ostrich to the tiny bee hummingbird, small enough to perch on the tip of a pencil. Birds have mastered the blistering heat of the deserts. Roadrunners, sand grouse, and some species of wren and sparrow are supremely suited to thriving in these inhospitable areas. Meanwhile, birds such as penguins, sheathbills, albatrosses, and skuas have conquered the poles, the coldest regions of the planet, which, for much of the year, are cloaked in ice and snow. Birds compose the most beautiful of all living creatures. The tropics are filled with some of the most brightly colored species of parrot, pitta, trogon, bird of paradise, hummingbird, and toucan, with beautiful, vibrant plumages suited to attracting mates and competing with rivals. In some areas of the world, birds are also extremely odd. Podus thrive in the inky blackness of South and Central American rainforests, where their piercing yellow eyes and screeching croaking call has become infamous. Some species of grouse and pheasant launch bizarre, fleshy appendages from their faces and throats when lecking to impress females. And even some species of ducks, such as eiders and scoters, could make the most seasoned wildlife enthusiast take a second glance. In some birds, the resemblance to dinosaurs is more apparent than others. The cassowaries of Southeast Asia and Australia are a prime example, with their sharp, blade-like claws, featherless necks, and bony head casques. The shoebill of Central Africa looks almost like a large theropod, with its bulky beak and menacing glare. In the forests of South America, baby hoatzins retain claws on their wings to grip onto branches that overhang the mighty Amazon River, giving off a distinct dromaeosaur look. The hornbills of Southeast Asia and Africa recall these ancient beasts also, with their reptilian facial structures and bizarre crests. The birds of prey retain the carnivorous nature of the extinct non-avian theropod dinosaurs. Creatures such as the majestic golden eagle and the great gray owl are almost like modern-day equivalents of the velociraptor. Agile, feathered predators that inspire respect and fear in us. However, even in the house of sparrows and blue tits that might frequent your back garden, the resemblance is still there. The claws and feathers, sported by even the most innocent-looking of birds, still recall the gigantic Utah raptor, that legendary feathered apex predator of late Cretaceous North America. The diversification and beauty of modern birds, or perhaps we should say avian dinosaurs, is what has driven the human race to adore them as such. Birdwatching has become a major industry in some regions of the world, where tourists will pay thousands to witness some of our planet's rarest and most majestic species in the flesh. Certain scientists devote their careers to the study of birds, ornithology, and we have learned much about them over the years. Still, there is much to learn, and many questions have been left unanswered. Throughout history, even going into prehistory, birds have influenced our culture. Ancient cave paintings of birds exist in some of the oldest settlements established by our kind, and birds are prominent across many religions and cultures throughout our species, those both archaic and those major in the modern day. Birdwatching has even been linked to improving our mental health. Spending time outdoors with our feathered friends can genuinely make us happier and healthier. So why not do it? Go out and discover the dinosaurs that still exist in your area today. Get to know them. You'll be surprised at what you might see at your local nature reserve across the year. We are lucky to continue to share a world with dinosaurs. Many species of bird may not live up to the nature of the infamous Tyrannosaurus rex, but the science has proved that these little fluttering creatures, prominent in art and poetry for centuries, are direct descendants of the amazing reptiles that once ruled our planet. Sadly, however, many species of bird are now under threat. Deforestation, the caged bird trade, and overhunting have driven many species of tropical bird to the brink of extinction. But that isn't all. Even locally, some species of birds are in danger of becoming regionally extinct in the areas in which they once thrived. Rewilding incentives and conservation efforts are doing all they can to protect this, but those in charge still need to do more to ensure that these amazing descendants of the Earth's most wondrous creatures persist long into the future.